Oh, hello, geometry students. Mr. Zacek back and better than ever here in Unit 7, Lesson 1. We've had kind of some preview things that we've been doing. And this also is a little bit of a review as we're going to get into eventually similarity, which we're going to start talking about in our next lesson. But we need to review some things about ratios and proportions. So a ratio is a comparison of two quantities by division. And so we have different ways that we can write that. One way to write it is simply as a fraction. A second way to write it is with a colon, A to B. A third way to write it is with the words A to B. The number being divided can't be 0. And so usually A and B, a couple key points, are going to be in the same units and in simplest form. Sometimes we can have an extended ratio of 3 or more numbers, so A to B to C. So an example of this would be like angles in a triangle might be one example, and we'll do some more there. And a proportion is an equation that states two ratios are equivalent. So an equation that states two ratios are equivalent. This has the extremes up here. So we're going to hit the extremes are A and D, and what are known as the means are B and C. And so when you have two fractions that are equal, use the cross product property. It's the product of the means equals the product of the extremes. It's the cross product property. When you have two fractions that are equal, use the cross product property. It's the product of the means equals the product of the extremes. It's the cross product property. And so when this is a little more kind of technical of a definition for what we've known and talked about before as to cross multiply. Well, the word product is the answer to multiplication, so cross multiply, we just want to kind of refine it a little bit more in geometry because we're going to use it in some proofs, and so we're going to call that the cross product property, CPP. Anyway, and this is an example of using that. All right, so when we're using ratios, there's two types of approaches that we have to it. If we only know a part, we're going to set up a proportion, put the like quantities across from each other, and solve, and this will give you the other part. So we're going to use the cross product property. The other scenario is if we know the total. We're going to make a let statement, and we're going to put x after each number in the ratio, add them to equal the total, solve for x, and then substitute those back into the let statement. So there's two different types of approaches that we have. One, we're going to use a proportion. One, we're going to use an equation. So if I was going to kind of just summarize this, like what method are we going to use? In this method, when we know a part, we're going to use a proportion. When we know the total, we're going to use an equation. And there's more to that, but that's just a short summary. All right, so let's look at an example. All right, what is the solution of each proportion? Okay, so the product of the means equals the product of the extremes. It doesn't really matter which way, which side you put it on. I like to put the x, if there's only one, on the left side of the variable. So 5x equals 24. We divide by 5. So x is 24 over 5. That's simplest form. Nothing goes into 24. Nothing goes into 5 in 24. Over here, what we need to be careful about on this one, so if we do 9 times y, we get 9y. Here we have to distribute, okay? So that's kind of an error point that people sometimes, they'll just make that right side 3y plus 4, and they forget that we need to distribute because we're multiplying those quantities together. So the 9y would equal 3y plus 12. If we subtract 3y, we would get 6y equals 12, divided by 2, and y is going to equal 2. Okay, so that's, just some examples here of this. All right, so a bonsai tree is 18 inches wide and stands 2 feet tall. What is the ratio of the width of the bonsai to its height? So as you read this, what I want you to notice is that we've got 18 inches and we've got feet, so we don't have the same units. So the first thing that we want to do is we want to convert it into the same units. So I'm going to go, since 1 foot equals 12 inches, okay, I'm going to convert 2 feet, so then 2 feet would equal 24 inches. So I'm going to replace 2 feet with 24 inches. Now the order here matters. What is the ratio of the width? The width is first to the height is second. So in our ratio, that's what we want to put that. So I'll write it a couple different ways. So I could write it as 18 over 24, but we also said you want to put it in simplest form. So 18 over 24 reduces, because 6 goes into both of those, to be 3/4. Okay, so we could write it like that, or we could write it, 3 to 4. Those are the most common ways. All right. Now, the question 3, 2 complementary angles in the ratio of 2 to 3. When you see complementary, remember the C is like 90. That's our little tool to help us remember. The larger angle measures 54 degrees. Find the measure of the smaller angle. Okay, well, you could kind of do this a few different ways, but I'm going to say let's let x equal, so 2 complementary angles in the ratio of 2 to 3. So let's let x equal, or 2x equal the smaller angle. Let's let 3x equal the larger angle. And we know the total and complementary, they have to add up to be 90. So this is where you make that equation. 2x plus 3x equals 90. So 5x equals 90. Okay, when we divide by 5, so if we take 90 divided by 5, what's that going to come out to be? 90 goes into 50 10 times, and then into 40 8 times. I think that's 18. So 18. So the smaller angle would be 2 times 18, which would be 36, or 3 times 18, which would be 54. Okay, so the smaller angle has a measure of 36 degrees. Now, since they gave us the 54, we could have done 90 minus 54 and gotten 36 that way. Okay, but I'm just trying to show you how to use this ratio piece. Okay, the lengths of the sides of a triangle are in the extended ratio 3 to 5 to 6. The perimeter of the triangle is 98. So the perimeter is an example of total. Okay, so what is the length? So instead of doing a let statement, what I'm going to do in this case, I'm going to draw a picture and just do 3x, 5x, and 6x. That's kind of like my let statement. So I do 3x plus 5x plus 6x equals the total, 98. So we add these together and we get 14x equals 98. And then we divide 98 by 14 and we get 7. So for our sides, we've got 3 times 7, which would be 21, 5 times 7, which would be 35, and 6 times 7, which would be 42. So that would be the length and the longest side. So then the longest side is going to equal 42. Okay, so always want to make sure we're solving the equation. All right, so last one here, and in the diagram we're given a proportion and what ratio completes the equivalent proportion. So we want this to be equal to it. So one of the tools I can do for A and B, here's how I like to think about it. It needs to be the product of the means equals the product of the extremes. So in this fraction here, in this proportion, the x should kind of be on the diagonal of the 7, and the y should be on the diagonal of the 6. Because when we do the cross product property, 6y equals 7x. So I look at this and I say, okay, am I going to end up with that same equation? And that would get me there. Now down here, I would have 6 and x. So again, 6 needs to be kind of on the diagonal of the y. And then 7 needs to be on the diagonal of the x. Okay, so you'll also notice that in the triangle here, we can look at some of those relationships between the side lengths. So what happens over here is now we've taken y and we've added 7 to it and we've put it over 7. And so if we take over here, what you can do is, see how y plus 7 is like the whole length of this side of the triangle? And over there, that would be x plus 6 over 6. Okay, so that's how you can kind of look at that and set up those proportions. All right, now you'll also see as we're doing these proportions, sometimes when we multiply, we do the cross product property, we're going to end up with quadratic equations, which is why we did that review work first. All right, and all of this is moving into what we'll get into in our next lesson, which is going to be similarity. All right, and so we're going to be looking at figures and talking about what it means for them to be similar. All right, so let's stay engaged, and I'll see you soon again on here.